In this video, I will be going over some of the review problems from the 6.4 and 6.5 review guide, which is all about simplifying radical expressions. And we'll also see a little bit on adding, subtracting, multiplying, and dividing, all of which will be covered over these two sections. And so for the first one I'm going to do here, number 2, we just need to break down the roots. And so we're talking about a cube root here. So 16 is not a perfect power. So then you're going to use your lists from section 6.4, and you're going to figure out what perfect cube goes into 16. And it's actually 8, and it goes in there twice. So I'm going to rewrite the 16 as 8 times 2. Now I'm going to go ahead and break down the root. We know that the cube root of 8 is 2. We can't break down this 2. I can break down the variable because this index of 3 goes into 5 once with 2 left over. 3 goes into 7 twice with 1 left over. So then the leftovers look like this. So I have the 2, and then once again the 3 went into 5 once with 2 left over, so that's x squared. And then 3 went to 7 twice with 1 left over, so that's y to the first. So then my answer would be 10. X times x is x squared, and then y squared, and then cube root of 2x squared y. One thing to remember about cube roots, and this is problem number 9, is that you can take the cube root of a negative number. So and I'll talk about number 8 while I'm here, while you can't take the square root of a negative number, you can take the cube root. And so I know there's 2 negatives here, but just think about the one underneath for a second. Think about this part. The cube root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2 is negative 8. But then if I bring down that other negative sign, it's going to change back to positive 2. All right, a couple more problems here. On the next page, number 13, you can multiply expressions together. So you take the outside times the outside, so 3 times 6. And then you take the inside times the inside, so 5 times 50 is 250. And then y to the third times y to the 5th, you add those exponents to get y to the 8th. Then you have a problem like the first one that we did today, where you just have to break down the roots. 125 is the perfect cube that goes into 250, and it does it twice. Now the cube root of 125 is 5. And so what happens is I have to take that 5, and I'm going to multiply it by the 18. So I'm not taking 18 times 125, I'm just taking 18 times 5, which is 90. Now I'm going to go ahead and break down the y. 3 goes into 8 twice with 2 left over. So that 2 left over would be the power on that y. And that right there is going to be my answer. Now you can also divide in the same manner. Okay, so you take inside divided by inside. But there are a lot of times, and I'm going to skip down to 16 here, that you might be messing with binomials, or you might have a monomial in the denominator. So in number 16, I just can't cancel the root 5s because there's a 2 minus. So this is a binomial, so I can't do any canceling. So I'm going to have to multiply by root 5 over root 5. So this is distribution. So that would be 2 root 5 minus, now root 5 times root 5 is just 5. And same thing in the denominator, root 5 times root 5 is 5. And once again, I can't just cancel the 5s because the numerator is a binomial, and you can't mess with that. So that is number 16. Number 17, notice there's now a binomial in the denominator, so this is where you multiply by the conjugate of that denominator. So I'm actually going to have to do some FOIL here, not just distribution. So up top, I will have 6 times 3, which is 18. 6 times root 3, which is 6 root 3. And then I'll have 3 times root 3, 3 root 3, and then plus just a 3, because root 3 times root 3 is root 9, and root 9 is just 3. In the denominator, 3 times 3 is 9. You'll have a plus 3 root 3, but then you'll have a minus 3 root 3, and that happens because they're conjugates. Minus root 3 times root 3, which is 3. So up top, 18 and 3 would make 21, plus, and then that would be 9 root 3 over 6. And it looks like everything is reducible by 3. Don't touch the root when you do this. 7 plus 3 root 3 all over 2. So very much like simplifying your answer for quadratic formula. And 18 is just a basic example of FOIL. So I'll go ahead and take 2 times 3, which is 6. And then I've got plus 2 root 18 minus 18 times 3. Oh, I'm sorry, that's not right. So that would be minus 3 root 3. Let me erase that real fast. Skipped my third part here. So I did 2 times 3, and then I did 2 root 18, so now I need this part right here. So minus 3 root 3. And then minus root 3 times root 18, which is root 54. So then I just need to break down all of these here. So I've got 6. Now 18 is 9 times 2. 3 root 3 won't break down. 54 would be 9 times 6. All right, so this would be 6 plus, so that would be square root of 9 is 3, so that would be 6 root 2 minus 3 root 3 minus 3 root 6. None of those are like terms, so then that's going to be my answer. All right, I've got one more here that I want to show you. It's on the last page. Number 25, when you want to add or subtract roots, and we kind of noticed it on that problem, you can't add or subtract them if they're not like terms. So the problem that we just did, number 18, none of these were like terms. No root, root 2, root 3, root 6, none of those roots match up. But sometimes you can break them down and they will match up. So for example, on 25, we know that we can break down 8 as 4 times 2, 32 is 16 times 2, and 12 is 4 times 3. So if I went ahead and just break down all of these perfect squares and multiply their answers out front, this would be 6 root 2 minus 4 root 2 plus 4 root 3. And you'll notice that these two can combine to give you 2 root 2 plus 4 root 3. So there are times where you can combine those if you break down their terms. I'm going to leave the rest to you. Let me know if you have any questions or concerns.